Heat pump water heaters with battery backup. We're lucky enough to be joined by Channing Street Copper Company. Many of us know them by their induction stoves with the battery backup. We're here, they're talking to us about a nascent project and looking for feedback also, a nascent project on heat pump water heaters with the potential battery backup. So Channing Street Copper, great to have you all with us. If you guys want to drive this slides, you can take control. There's a button at the top. Otherwise, I can do it for you. So either way is easy.
That seems fun. I think I can press buttons and make it go. Hi everyone. I said hi a little bit earlier. Josh Land here. Got Andrew Browning with me.
Hey, how are you?
We're working on, as Joe said, battery integrated induction stoves, but we have recently got some funding from the Department of Energy to put that same kind of technology into a few different products. That the focus of attention here is the heat pump water heater. So idea is we integrate, a battery bank pretty much into a heat pump water heater. Overall idea with this technology is to electrify more homes, get folks more off of natural gas, and then move into more decarbonization across the grid. There's a lot of fossil fuel burning machines out there, and about 500 million of them need to be retired in the next 25 years. You all kind of are familiar with this, the standard duck curve, what's going on. If we can shift how we use our energy and when we use our energy and when we store that energy, it can really flatten that duck curve overall.
Hey, Josh, real quick, I think
yes,
I'm still driving this. I think I'm still driving the slide, just for FYI. You can move them, but you have to take control of the screen if you want everybody to see what you're seeing. Otherwise, I can just keep.
Gotcha. Why don't you, go ahead and go to slide 16 then.
Okay, yeah, I'm on 16. Perfect. Yeah.
I'm just gonna let them go. Okay, I think I have it now. Does that look right?
Yep.
We're on 16.
Yeah, you've got it now. Yeah, perfect.
Great, thank you. All right, moving forward. So yeah, what we do with our stove so far, what makes this nice is that we make plugging into a 120 volt outlet possible. We're able to pull energy from the battery and the wall at the same time, so you don't have to have a 240 volt plug behind where your stove usually goes, in this case, water heaters. Cuts down a ton on installation costs, especially for retrofits, and makes it easy for utilities as well as in load shifting and just avoiding full upgrades both to homes and to neighborhoods. Let's see. So we're in the first few steps of building out our water heaters over here. Andrew's taking charge of that. Kind of the few couple things we're looking at right now is just being able to have a quicker hot water recovery time. If you are recycling through, a tank of hot water, we want to be able to come back and get more hot water more quicker. So we are putting resistive elements in into our hot water heater our water heater that is, along with the heat pump. That will help just pull power from the battery and kind of dump it into the water a lot quicker if you're trying to go through a few different tanks in an afternoon. And yeah, it enables that still for enables the heat pump to still operate off of 120. That's kind of the main plug there. This is kind of like something we're looking at. We're mostly looking for feedback from everybody here. You guys are a bunch of experts, and we're kind of new to this world. Wondering if in the next few minutes you have some comments, some questions, some advice, like what maybe are some of the focus and what are some of the attributes that we should be focusing on in the development here. We're new to this game. We've been making stoves for about 3 years now. We're feeling really good about that. We're in the manufacturing stage, and we feel confident in making induction stoves with batteries built in. But any feedback, any questions, any advice from the hot water specialists out there? What do you all think?
Hey, this is Dom from Block Power. How are you doing?
Hey, Dom, how's it going?
Yeah, can you confirm? My understanding is the battery actually supplies an electric resistance, right? Correct?
The battery supplies the entire unit. So there is no connection between the wall and the actual water heater unit or any of its elements. that is entirely driven through the battery, and the battery is connected to the wall.
Okay, so the battery should supply, as a priority, should supply the heat pump, right? Which is more efficient than the resistive heating, right?
It'll be a bit of both. So while yes, ideally we'd be pulling from the battery whenever we can. If there's a time where it's the battery's gone low, we'll be pulling from the wall. And if there's a time that we can pull from both the battery and the wall at the same time, that's totally fine too. Depending on the time of day and the needs of the system at one time, we'll kind of adjust from there.
Okay, thank you.
Go ahead, Joshua Pierce. And yeah, folks, please raise your hands. We can have a nice order to this. That'd be great. Thanks. Go ahead, Joshua.
Hey, thanks. Cool stuff, guys. Been following your progress and excited to put a few units in when you've got some scale going. Couple of quick questions, mainly about the capacity of the battery in terms of amount of water to be heated. So I'm assuming you've done some calculations, and what can you share with us about both the boundary conditions, sort of like, worst case when you're just doing resistive heating, and best case when you're using battery capacity for just through the heat pump, sort of what amount of hot water, what kind of recovery time can you give us in terms of just battery capacity and its ability to heat water in whatever metric or measurement you want, whether it's BTUs or gallons?
This is one of the things that we would both like feedback with and will test, but generally speaking, in our other systems, the battery is not sized for energy capacity. The battery is sized for power output, which tends to give us an excess of energy capacity. The battery is really there so that we can match the performance of, like, say, an off-the-shelf hybrid 240 volt hot water heater or whatever, using 110 volt 15 amp infrastructure, right? That's the primary objective, right? We're not trying to necessarily have energy storage so that we can provide off-grid hot water.
Right.
So sizing the batteries right now, we need to size it as small as possible while still being able to achieve the power output that we need for that to function. However, there is a cost balance, obviously, of like, do we add more storage, and is that a cost-effective way of either getting grid storage on the grid or getting a more effective consumer product?
Makes sense. Okay, thanks for the clarification. I guess my follow-on question then would be, given the fact that you're trying to match performance with a 240 volt unit, but you're doing it in a tank with that's half the capacity. I guess that would be my first piece of feedback, is if you're trying to match performance, your recovery time has to be significantly faster in order to be able to, or from an event-driven perspective. And that's going to be tougher to do since you're drawing off 110 volt power.
Right. I mean, for that quick recovery time too, just dumping all of the energy from the battery into the water by way of resistive elements is a huge win. That gets a lot of hot water, gets a lot of water hot quickly. And that's kind of what we're shooting for. That, I think maybe you're referencing this last slide over here, because it says the 30-gallon tank. That's an idea, that's a rendering. We're toying with different sizes right now. Not confirmed that's like our 100% go-to, but that's an idea we had. So we're doing our testing, and if you got ideas, lay it on us.
All right. Well, I think we have a lot of hands going up, so let's keep moving down the list. Thanks, Joshua. Appreciate it. Owen Howlett, co-lead of the working group. Go ahead.
Hey there. I'm really glad to see this product. It's great to see this happening. I have a couple of questions as a regulator.
Sure.
What you have here is two devices in one, right? You've got a battery and you've got a water heater. What happens at end of life when one or other of those, probably the water heater, fails? Does the battery have an ongoing life beyond the end of life of the water heater, or can it be added to a new water heater? How does that work? And then second question, do you anticipate that the battery will be able to take part in load shifting programs, or is it more or less it just has one job, and that's to be a backup for the water?
Yeah. For second question first, absolutely, we'll be taking part in demand response. That's kind of not a primary thing, but definitely something we're looking at and taking part in already with our stoves. We're just developing our virtual power plant system as we speak with the battery and stoves. That'll definitely extend to water heaters and other products that we'll have out there. Very excited about that. So for sure that'll be a part of it. The recycling aspect, yeah, you're saying, can the battery go on if the water heater dies, and can the water heater go on if the battery dies, kind of a thing. Yes, we have kind of, depending on where these are, we're looking at, New York and California as our first kind of launch sites for the stove and then the water heater as well. There's different battery recycling programs and replacement programs depending on where you are. We are all lined up with those already and able to do service calls if there is like some kind of battery failure. Then we'll definitely be addressing that. We do have our battery warranted for, I think, 10 years is what we're looking at for New York right now for the program we're taking part in out there. And that'll extend to water heaters as well.
Yeah, and I'll jump in and say on the back end, our grants for both the heat pump water heater and for the stove work that we've done previously have dependencies on recycling and second life applications. So there is work being done both by us and also generally by this grant ecosystem to try to solve that problem. Obviously, it's quite complicated.
Thanks. That's great. Okay, Edward, and for folks asking questions, could you just say your name and your organization? It'd be great.
Hello, great product, or great idea for a product. And my question is about the power electronics and how you will be able to shrink the power electronics small enough so that it will fit in the kind of space available around the tank or on top of the tank. And so the question is, do you plan on like using high voltage lithium batteries so that you're just converting 120 to like something like a 240 volt DC to charge the battery and then run the elements off of DC and the compressor off of high voltage DC also? Or can you speak more about those things?
Yeah, we have no AC power conversion. We're running everything directly on DC, high voltage DC.
And in short, perfect. Yeah, we shrunk things in a reasonable way to put it into a stove, and we feel good about putting it into a water heater as well. Is the I guess high level answer to shrinking down the power electronics.
And then is that compressor going to be single speed, or are you going to use some sort of brushless DC motor speed controller so that it is a variable speed compressor?
Yeah, unclear at the moment.
Unclear. Okay, thank you.
Well, just Edward Louis is a great guy to be chatting with Canadian Pacific Copper team from Pacific Northwest National Lab. So might be a good person to bounce ideas off of. Try to back for that show. Great. I'll next we'll go to Chris Granda from Energy Solutions. Go ahead, Chris.
Let's see. Hi, can you see me? Yeah, there we are. Yeah, great. Thanks for introducing this really interesting product. I guess I see this as being, competing with, I mean, this is the thing about water heaters, right? Is that they already have energy storage. So where this looks attractive to me is in space constrained situations, and also for 120 volt applications. I was wondering if you could talk about the size of that 30-gallon package, with both the compressor and with the battery, as compared to a conventional electric resistance water heater. And also, do you have plans to run it through DOE's new test procedure for effective storage volume? Because I think that could be really interesting as well.
Yeah, we are going to have to go through that. Again, with the 30-gallon tank, 30-gallon plus battery plus heat pump, we are in prototype stage, so I can't really give you like a apples to apples comparison of like what the final product with all the bells and whistles included would look like compared to like say a 50-gallon water heater right now. If the heat pump will obviously add a little bit of size. Batteries, we hope, will not add too much. We've done a good job of really slimming down our pack and still retaining a good amount of storage for our stove, and we're still figuring how that kind of architecture will look for the water heater itself.
Yeah, I guess,
And-
and maybe just to underline
Go ahead,
Chris's point, though, the small form factor is something we keep hearing again and again. There's various attempts to create solutions to the small water heaters, because usually the current heat pump water heaters on the market are large tanks with large storage. So
yeah, one of our colleagues actually has this problem right now, and so we're using her house as a sort of test bed for a small form factor. So that's one of the things that I have in development at the moment.
And happy to take all questions all day long. I know you have other folks to talk to, Chris, or sorry, Joe. We can keep going, but it's up to you on your scheduling. That said, I don't think I put my email on here. If anyone wants to email and chat after this, it's josh@channingcopper.com. Maybe we'll pass that out afterwards as well.
Yeah, I think we have time to do two. Let's go our last two. That John, I saw you just put your hand down. Did you want to ask your question quick, and then we'll go to Ram? I'm calling out from Slipstream.
Yeah, I had a question which John Neal actually just put in the chat, which is what is the but it sounds like maybe you haven't landed necessarily on this. When you think about amount of water you can heat up quickly versus size of battery that you can, have in there. Like I'm basically comparing the size of the battery that you will need to heat a certain volume of water up to like 120 versus storing that water at 145. What is the like trade-off in size? Is it half as big? Is it
right?
That's the matrix. that's the thing we'll be playing with, and like figuring out what kind of mixing valves we want to have on there, and if and when, and then the quantity of water, and who's going to use it, and is it going into multifamily, or is it going into single family residential, and so on and so forth. So we
at the end of the day, it's like roughly trying to figure out what the balance is between necessary performance for most people and cost. So
and this is noting target. Something else in the chat too, which is like, you can always, and I think you maybe reference the split system for a second, but not having to displace the volume of water with a battery is pretty attractive. I think we've seen form factor to be pretty limiting. With the 120 volt water heaters that we're installing at larger sizes.
That's really interesting. Okay, cool.
Okay, why don't we go to our last question, Ram Narayana Murthy from Department of Energy. Go ahead, Ram.
Hey, Joe. Thanks for letting me jump in. Just want to say I'm actually quite excited that we are moving in this direction of getting small form factor 120 volts. In fact, I think when we started this whole journey 6 years ago, that's where we wanted to go, and I'm glad that we are getting there. But I think it's important for us to realize that we have to have these product lines, the 30 and 40 gallons that can run up 120. And so I'm really looking forward to the results. Also wanted to mention that there is another project that we are starting with the Colorado School of Mines to do a split system 120 volt water heater. So just very excited about these new products coming to the market, especially as we look at affordable housing and multifamily. I think these are key innovations that we need.
Cool. So, if you could send us an email, either Josh at Channing Copper or Andrew at Channing Copper, about that program at School of Mines, that would be very interesting to look at what you're doing.
I'll check
so
it
it's
out
actually through the benefit FOA. So
nice.
I will ensure
that's what we're working on too.
I mean, so
you know that.
I think it isn't the same. I think it isn't the same award set. So just want to make sure that we are getting all the pieces put together. But it'll be great for you all to connect and see how we can get all these innovations put together so we can scale them out in the market.
That's great information. Thanks, Ron. Appreciate it. I'll put my email in the chat so people can reach out.
Okay,
as well.
Great. Well, I'll connect back. Okay, I'll connect back.
Cool. Thank you.
Thank you. Yep.
Great, and I can facilitate that as well. The Colorado School of Mines team will hopefully be on. We're looking at a summer timeline there. They won, as Ram said, a benefit award and are going to be launching, I think, in the next month or two. So they preferred a summer time to come on and talk to the working group. So Josh, just any last thing to leave us with? What's the timeline looking like for developing this prototype?
Yeah, we just kind of kicked off this project in the last couple of months here. So we're tinkering right now. Product to market. Give us a year a year and some, hopefully, if it was a year, it would be moving quick, but hopefully we get things out there. We'll be doing a lot of testing over the next year, and we'll keep you all updated.
Cool. Well, look forward to seeing the prototype as it develops and having you on again and to give updates. So thanks so much for being on, to both of you. And yeah, thanks for
Thank you.
being here.
Yeah, for sure. Thank you.